Hey math kids, today we're going to talk about improper integrals. I have something written on the screen already, and they're going to ask us to evaluate from 1 to infinity of 1 over x cubed dx. Alright, so we're just going to use this formula. We're going to say the limit as b approaches infinity from a, which in this case is 1, to b, and we have our function. And so what we're going to do next is just take the antiderivative. So I'm going to think of this like x to the negative 3. So it's x to the negative 2, negative 1 half. Evaluate that from 1 to b, and we still have the limit as b approaches infinity out in front. Okay, so I plug in b, I get negative 1 half b to the negative 2 minus negative 1 half 1 to the negative 2. And then I still have the limit as b approaches infinity of all of that. Okay, now this, if I just simplify this, I get negative 1 over 2b squared. And that's really just 1. 1 times negative 1 half times negative is going to be positive 1 half. And then if we apply the limit, if we put infinity down here, if we get and we square infinity and then times it by 2, it's a really, really big number. 1 divided by a really big number, when we're talking about limits, is 0. And so our answer to this is just 1 half. Alright, this next one, we're going to say a infinity x e to the negative x dx. Okay, and this just equals the limit as b approaches infinity from a to b, x e to the negative x dx. Okay. Now, if we do integration by parts, we're going to say u is equal to x, v prime is equal to e negative x, u prime is equal to 1, v, if we do the antiderivative, we end up with that. So we get x times negative e to the negative x minus the integral of 1 times negative e to the negative x dx. And all of this is the limit as b approaches infinity. Okay, so let's simplify that. Negative x e to the negative x minus negative e to the negative x dx. I'm going to take this negative out. Just to make it a little bit easier, this is still the limit as b approaches infinity. Okay. Now, when we, let's see, so this would still be from a to b because it's a definite integral. And if we take the antiderivative of this, it's negative, it's this. I can't talk right now. And so this one is also from b to a. And all of this is still the limit as b approaches infinity. Okay. So if we plug in b right here, we're going to get negative b e to the negative b. And then we'll subtract negative a e to the negative a and then we'll do this one. Negative e to the negative b minus negative e to the negative a. So that's just a plus sign. And once again, this is still the limit as b approaches infinity of all of that. Okay, I think at this point we can plug in our b. Maybe not. Let's see. What can we take out? We can, let's try to combine these actually first. So we have a e to the negative b, e to the negative b right here. So we're going to say e to the negative b, and then the stuff that we get negative b minus 1. And then those negatives will make a positive. We can take out a e to the negative a, and we're left with a plus 1. Okay. And if we still have our limit as b approaches infinity. All right, let's write this in a little bit different. So limit as b approaches infinity of negative b minus 1 e to the negative b. Now over here there's no b's involved, so we don't really need to worry about that limit anymore. So we just have a plus 1 over e to the a. Now if we're trying to take this limit, if we plug in, whoops, I brought this to the bottom, so that's not negative anymore. If I put in an infinity here, it's going to be e to the infinity, which is infinity. And if I do negative infinity here, actually how I'm going to look at this, I'm going to pull out a negative 1 here and change these signs. So if I put infinity in here now, we're going to get infinity over infinity, so that means we have to use L'Hopital's rule. Okay? So we want to take the derivative of each of these, so that's just going to be 1. I'm going to bring the negative back in from there, and then we're going to get e to the b. So now, if we take the limit as b approaches infinity of that, it's going to be negative 1 over infinity, which goes to 0. So all of this goes away, so we're just left with a plus 1 over e to the a, which is our answer. The book left it as this, which is the same thing. If you have additional questions, please come to Math Lab. Until then, calculate.